Right now, Oumuamua is still accelerating away from our solar system, and every physicist at NASA, Harvard, and Caltech has no way to stop it, track it, or explain what just happened. It moved in ways nothing natural should move. And what scientists found when they ran the numbers is the part they are afraid to say out loud. But here's what nobody is telling you. It appeared in October 2017. A faint streak across a telescope image from Hawaii. At first, astronomers thought it was a comet. Then they looked closer. No tail, no gas cloud, none of the things comets do. They named it Oumuamua, a Hawaiian word meaning messenger arriving first from afar. It was the first interstellar object ever detected passing through our solar system. Not from here, from somewhere else entirely. It came from the direction of the constellation Lyra, moving at roughly 196,000 miles per hour. That is fast enough to escape the sun's gravity without breaking a sweat. We only spotted it while it was already leaving. We had weeks to study it. And in those weeks, it showed us something that shattered the models completely. Here is where things stopped making sense. As Oumuamua moved away from the sun, it sped up. Not because of gravity, not because of any force astronomers could identify or measure. It accelerated beyond what known physics allows for an object its size. Scientists call this non-gravitational acceleration. That sounds clean and clinical. Here is what it actually means. Something was pushing it, something invisible with no detectable source. They checked for cometary jets, plumes of gas that act like natural rocket engines. Nothing, not a trace of gas or dust. They ran the data again and again. The acceleration was real, it was consistent, it was directional. And it was pointed away from the sun at exactly the angle needed to maximize speed. That does not happen naturally, not randomly, not once in the entire recorded history of astronomy. The easy explanation is solar radiation pressure. Sunlight does push objects. We call this the Yarkovsky effect. We know it exists, but for radiation pressure alone to explain what Oumuamua did, the object would need to be impossibly thin, less than a millimeter thick, but potentially hundreds of meters across. A flat sheet drifting intact through interstellar space across light years of travel. No natural process we know of makes that shape. No known force keeps it together across that distance. When Harvard astrophysicists Avi Loeb and Shmuel Bialy proposed this geometry, they were not speculating wildly. They were doing math. The math worked, and that terrified people. Because if it is not a natural shape, then the question becomes something institutional science is deeply, visibly uncomfortable asking out loud. And here is the part they are afraid to say, the thing we promised you at the start. In 2021, Dr. Avi Loeb, the former chair of Harvard's astronomy department, published a formal case. Not a blog post. Not a fringe theory. A peer-reviewed argument. Oumuamua had the wrong shape, the wrong trajectory, the wrong acceleration profile for any known natural object. And when you model its behavior against solar pressure, what you get is a near-perfect match for light sail propulsion. A thin, reflective surface pushed by starlight. The same technology humans are actively developing right now to send probes across interstellar space. Oumuamua behaved like a functional, already deployed version of that technology. A version built by someone else, already operational, already passing through our neighborhood before we had even finished designing our own prototypes. And here is the part that should sit with you. It came from a direction where we have found no star, no source, no origin point we can name. Something launched it, or it launched itself from empty space, and it used our sun's light to accelerate on its way out. We were not the destination. We were a fuel stop, and we barely noticed in time to watch it leave. But here's the strange part, and this is the thing that keeps scientists quiet at conferences. That behavior should not be possible at all for a passive, drifting rock. Not even close. This changes everything about the question we have been asking. We spent decades asking whether life exists out there, treating the answer as almost certainly no until proven otherwise. But if a single object, one, moves through our neighborhood and behaves like manufactured technology, the burden of proof reverses. It is no longer on the people who suspect something. It is on the people who insist it was natural to explain the acceleration, the shape, the silence, the trajectory, all of it at once. Either physics has a gap we have never found, some undiscovered process that creates flat, accelerating, non-outgassing rock, or something passed through here, something engineered, something old, something traveling between stars the way we send probes between planets. And if it was not the first time our solar system was used as a waypoint, then the real question is not whether we are alone. The real question is whether they already know we are here. So ask yourself this. If Oumuamua was strange in exactly the right ways, the shape, the movement, the silence, the perfect exit angle, what does that tell us about who sent it? We do not know. The scientists will not say. Not officially. Drop your answer below. Because that question is still out there, accelerating into the dark, and nobody is going after it.